Hello, welcome to Unit 6, Lesson 18, Subtraction in Equivalent Expressions. Let's take a look at our first activity. For this activity, you are going to find each sum or difference mentally. Go ahead, pause the video, and work on each one. All right, so negative 30 plus negative 10, well, that's just equal to negative 40 because we're starting negative and we're getting more negative. Same thing here. Even though we flipped it, we're still equal to negative 40, and this is due to the commutative property. If you recall, the commutative property tells us that when it's addition or multiplication, we can flip the numbers around and our sum or product will still be the same. For this one, in my head, I'm thinking that this is negative 30 plus negative 10, which is negative 40. And then this one, I'm thinking it's 10 plus 30, which is 40. Now, the key thing I want to point out here is that you cannot use the commutative property because the commutative property only works with addition or multiplication, and since this is a subtraction problem, we cannot utilize it. So those are just some key ideas for that first activity. Let's move on to the next activity. All right, this one says Lynn and Karan are trying to calculate 7 3/4 plus 3 5/6 minus 1 3/4. Here's their conversation. Lynn, I plan to first add 7 3/4 and 3 5/6, so I will have to start by finding equivalent fractions with a common denominator. Karan, it would be a lot easier if we could start by working with the 1 3/4 and 7 3/4. Can we rewrite it as 7 3/4 plus 1 3/4 minus 3 5/6? Lynn, you can't switch the order of the numbers in a subtraction problem like you can in addition. 2 minus 3 is not equal to 3 minus 2. That's true, but do you remember what we learned about rewriting subtraction expressions using addition? 2 minus 3 is equal to 2 plus negative 3. So first, you're going to rewrite this as addition, and then second, you're going to use Karan's method to answer the question more efficiently. Go ahead, pause the video, and work on that. All right, so let's go ahead and first rewrite it as addition. So this becomes 7 3/4 plus 3 5/6 minus 1 plus negative 1 3/4. And then now I'm going to apply that commutative property and put 7 3/4 and negative 1 3/4 next to each other. Oops, like so. And take it one step at a time. So first, I'm going to subtract these. 7 minus 1 is 6, and then 3/4 minus 3/4 is just cancels out. So you're just left with 6 plus 3 5/6. And then here, because it's addition, I can just add the 6 and the 3 to make 9 5/6. A whole lot more easier than if we had first added these two and then subtracted. So reworking the problem sometimes makes it a little bit easier to solve. All right, next activity. Alrighty, for this problem, we're going to be thinking back to something you learned back in 6th grade about the distributive property. Let's imagine that we have a rectangle that looks like this, and we can split that up. So let's use this rectangle to write an expression for the overall area a couple of different ways. So one way we can think about this is the area of one rectangle, which is 2 times 5, plus the area of the other rectangle, which is 2 times 3. So I could write it like this. Okay. So 2 times 5 plus 2 times 3. Another way to think about it is if I said, oh, I'm taking 5 plus 3, which is the length of the entire rectangle, and multiplying it by the height of the entire rectangle. And another way to think about it is, well, 2 times 5 is 10, 2 times 3 is 6, and 10 plus 6 is 16. So many different ways. You could go even further into what this would look like, but there are different ways to represent this. Now, last year when you did this, you only worked with positive numbers. This year, we're going to be working with negative numbers. And although we don't really find the area using negative numbers, we can still use this model to help us find the product or the area, and especially so when we start adding variables in. So go ahead, pause the video. You have 3 questions that you need to complete, and then when you're done, you can come back to the video. All right, so let's write 2 different expressions for the area of the big rectangle. So the overall big rectangle, I know if I add these sides up, that's 8y plus x plus 12. None of them are like terms, so I can't add them. I can't put them together. And I'm going to multiply that by the height of the rectangle, which is 1/2. So that's one way of doing it. Another way of doing it is finding the individual area of each piece. So for example, 1/2 of 8y is 4y. 1/2 of x is 1/2 x. And 1/2 of 12 is 6. So another way I could do this is 4y plus 1/2 x plus 6. All right, let's look at question 2. This one says use the distributive property to write an expression that is equivalent to 1/2 times 8y plus negative x plus negative 12. So a couple of different ways to think about this, and I'm going to show you 2 different ways. One way is use the boxes, right? 1/2 of 8y is 4y. 1/2 of negative x is negative 1/2 x. And 1/2 of negative 12 is negative 6. So you would end up with 4y plus negative 1/2 x plus negative 6. Now, question 3 has us doing the same thing, but using the distributive property. And if you recall, last year you learned that the distributive property tells us you can pass out what's in front of the parentheses to everything inside through multiplication. So this becomes 1/2 times 8y plus 1/2 times negative x plus 1/2 times negative 12. And in doing that, 1/2 of 8y is just 4y. 1/2 of negative x is just negative 1/2 x. And then 1/2 of negative 12 is negative 6. So that would be the same as what we did above, just written as a subtraction problem instead of as an addition problem. So that's it for today's lesson. Remember, you cannot use the commutative property when it's straight up subtraction. So 2 minus 3x and 3x minus 2 are not equivalent to each other because you can't just switch them. You would have to first rewrite them as addition, and then you can switch it to negative 3x plus 2. Those two are equivalent to each other. And then also when we talk about the distributive property, you can use the area model to help you distribute. And just note that if you have subtraction problems, you do need to change those to addition first so that you can recognize that there are going to be negatives. That's it for this lesson. Thanks for watching.